Hello, can you hear me? Hello, can you hear me?
Yes.
Yes.
All right. Let us begin then. I will start by showing you what is due today. I mean, today and then this week. So let me make sure you can see my screen. I believe you can. This is week 9, and these are the assignments that are due. We are still in chapter 4, and we have 2 assignments that are due this week. First of all, is classwork 8. The other one is homework 5. I extended the due date to March 26th. Let me take down the names of those who are in the class so far. And I got, who is Bryce? Who is Bryce? Got Antonio Phillips. Got Benjamin. Okay. White, Brenna White. I got, who is Bryce? What's your full name, Bryce?
Bryce Barnes.
Okay, I got it. I got Delany Mayu. Demi, who is Demi? Demi.
Yusuf.
Oh, Yusuf. Oh, Yusuf. Okay. All right. I got Nadira. Martin.
Here.
Onassis. Shemaiah. Shemaiah, what's your last name?
Smith.
Smith. Shemaiah Smith. Yep, got it. Hines. I got Hines. Hello, Hines.
Here.
I think that's all I got for now. All right. Let us begin. So today we're finishing chapter 3. We have the last topic in that chapter, and it's called Bayes theorem or Bayes theorem. I mean, it depends on, you can pronounce it the name anyhow you like, so long as you get the point that I'm trying to make there. So our goal when Bayes theorem is basically an extension of the conditional probability. We did it last time we were in class. So under Bayes theorem, we are trying to calculate the probability of A given B from the probability of B given A. So the main highlight of the theory is this. Suppose that we have 2 events. Suppose 2 events have prior probabilities of PA1 and PA2. Then events A1 and A2 are called prior probabilities because they are determined without any information. Now, our goal, like I mentioned, is to find the posterior probabilities, PAI given BI, and both the prior and posterior probabilities. When we say prior and posterior, I mean the probability before and after. Okay. So with that, we can now with this background information, we can now calculate the probability of the event using the Bayes formula. According to the formula, it says, let event A and B, or even A1 and A2 be mutually exclusive events, and assume that we have conditional probabilities, probability of B given A1 and probability of B given A2. Then the probability of event A1 given B, this is the formula, means probability of B given A1 times the probability of A1 divided by the probability of A B given A1 times probability of A1 plus probability of B given A2 times probability of A2. Now, this thing, if there are two events, if there are three events, you can continue, like here. If there are three events, you can continue to the third event. And if there are four events, you can continue. I mean, talking about the denominator, you can see you get for A1, you get for A2, we get for AN, where N can be any number, it can be A3, A4, A5. Now, usually when we are doing this, when we are looking at the formula like this, they look like monsters, but actually, when we apply them, we see that they're not that bad. Okay, so let us see how this works. I'll use this example to illustrate them. Let me give enough room for this. Okay, he said that the Pinnacle Bank, PNC Bank, classifies its credit card customers as into three categories based on their credit scores. So they classify its credit card customers into three categories based on their credit scores. Excuse me, if I don't mind. Person is a new person. 1 minute, let me see who this person is. Give me 1 minute. I didn't see him again. All right. Anyway, the PNC Bank classifies the credit card customers into three categories by their credit scores. Suppose that the bank has the following information about the customers. Customers with credit scores of less than 600 are late with their payments 40% of the time. Customers with credit score of between 600 and 700 are late with their payments 10% of the time. And customers with credit scores of more than 700 are late with their payments 5% of the time. Now, they give us a table that have these customers. Okay, the size of these customers based on their credit scores. Customer A1, that's the first group, has among all their customers, there are 25% of them have credit score that is less than 600. Then 45% of them, which is 0.45, have credit score of 600 to 700. Then 30% of them have credit score of more than 700, which is 0.3. So now it says calculate the probability that a customer has a credit score of less than 600, given that he or she is late on his or her credit payment. Now, remember they give you the probabilities of their default. They say for each category of credit score, which we call the prior probabilities. Okay, they give it to them that those who have a credit score of 600 are late 40% of the time. Blake. 1 minute. Okay, so, and they also say that customers with credit score of 600 to 700 are late with their payments 10% of the time, and customers with credit scores of more than 700 are late 5% of the time. And then they give you the size of these customers in percentage here, and they want you to calculate the probability that the customer has a credit score of less than 600, given that he or she is late with a payment. To do that, we need to identify what we are trying to calculate first. We have B, let the B be the customer is late with his or her current credit card payments. We use B to represent that. But we can say, okay, let A1 be credit scores of less than 600, because the question says that the customer, find the probability that the customer has a credit score of less than 600, given that he or she is late on her payments. Okay, so let be that the customer is late in his or her payments. And let A1 be that the customer has a credit score of less than 600. Why do we use A1 for that? We just choose to use A1 for that group. We use A1 for those who have credit score of 600 or less. And we use A2 for those who have credit scores of 600 to 700 or less. And we use A3 for those who have more than 700 credit scores. So this is what we're looking for here. Now, let us put the prior probabilities. Now, the bank customers in each group based on their credit scores. We have first one is for those who are 600 credit score, they are late 40% of the time. I mean, it's 0.4, 0.4, 0.4, or 40. And those with a credit score of 600 to 700 are late with their payment 10% of the time. So A2, sorry, 0 point, okay, 10. Okay. Then, excuse me. We have our information. Next one is the those who are late with their payments. Those with a credit score of 700 are late with their payments 5% of the time. So we have this 5% of the time, 0.05, 0.05, because it says 5% of the time. 5% of the time. Okay. Here you can see 5% of the time right here. So now, the probability we're looking for is this, that the customer has a credit score of 600 or less, given that he's late or she's late with her payment. That means the probability of B, A1 giving B, where A1 means that the customer has a credit score of 600 or less, and B is that he or she is late with her payment. So remember that B is the customer is late with his or her payment, and A1 is the credit score of less than 600, which is what they asked us to find. They were asked to find the probability that the customer has a credit score of less than 600, given that he or she is late with the payment. So now, I have given you what they have. They give us the size of each customer in percent, and the chance of them defaulting or being late are given. So all we need to do is to plug this into this formula. So using the bias formula, we have this, that the probability that the customer has a credit score of less than 600, given that he's late with payment, which is B, is the probability of B given A1 times probability of A1 divided by probability of the probability of B given A1 times the probability of A1 plus. So you do it for all the events. There are 3 of them. For the second one, you have the probability of B given A2 times the probability of A2. And for A3, even A3, you have the probability of B given A3 times the probability of A3. So plugging these numbers, we are going to have this. I'm going to, let me write it down. But I will show it to you by writing down. I will show you the first one. Probability of B given A1 is right here. They are late with their payment. Given A1 is 0.40. Probability of B given A1 is 0.40. And the probability of A1, which is that it is the first customer, is 0.25. So for this part, you repeated this here. So for this one, it's the probability of B given A2. Okay, that the customer is late, given that A2 is right here, 0.10. And then probability of A2 is right here, 0.45. So now I'm going to plug them all in. Let me write it on paper, and then I'll plug them all in, and then we do it together. writing it on paper, I think I have it. So I'm gonna just go and plug them in. I'll show you this. We need to have a workbook. So we go to our workbook where it will allow us to put the formulas in. So we're gonna have it the probability of B, excuse me. I'm sure you can see it. Good. Yeah, the probability of B given A1. Okay, sorry, A1 giving B, I need to say. I mean, it's the first group of customers. A1 giving B, okay, A1, okay, giving B, okay, equal. Now, before I do that, let me refresh your memory again. This, given this formula, the probability of B given A1, that's the customer defaulted, given that he belonged to A1, is right here, 0.40. And the probability of A1 is right here. And the probability that the customer defaulted, given A2, is right here. And then the probability of A2 is right here for that group. See A2, this. And the probability that the customer defaulted, was late in payment, given A3, is right here. Times the probability of A3, which is here. So all you need to do is just plug these numbers in the formula. That's what I'm doing in the next workbook. So let's go to that workbook where it will allow us to put this information, and then we can now transfer it to this one. So I'm going to have it here. So the first group is, I wrote it on paper, 0.25. Okay, times, excuse me, I missed this. Give me a minute, let me put this in right equation. Okay, good, back. Okay, times, the screen is messing me up. Okay, good. They're all out now. So I'm gonna get the times. Okay, times the probability of AI, which is 0.40, then over, yeah, then, remember when you go to the denominator, you see that you repeat that part again. So you repeat it again, probability of B given AI times the probability of AI. So, which is basically 0.4 times 0.25. Then repeat it for the rest of the events. So again, taking you to that section where we plug in our numbers. So we're gonna have 0.25. Let me put it in parentheses so that 0.25 times 0.4. Then for the second event, remember the second event is this. It is the probability of B, which means that the customer is late, given A2 times the probability of A2. So that means basically 0.10 times 0.45, since they both represent A2. So I'm going to take you back to plug this part in. So I got plus, we got 0.45, 0.45 times the probability of A2, which is 0.10. Then the last event, if you remember, the last event in the group or in the equation is this part, probability of B given A3, which is basically this one, times probability of A3, which is 0.30. Okay, okay. So you have we put it in. Go and put it in right. Okay, right. Belong. So 0.05, 0.05 times probability of 0.30. So actually, this is how it would be. Like here, this is 0.10. I put it in the wrong order, but it doesn't really matter because so long as both of them are there, 0.45. Okay. The same thing. I think we are good. I think we are good. 0.45. 45 doesn't really matter. So long as the two events are there, it doesn't matter the order in which you multiply them, because commutative law, according to the commutative law, A times B is the same as B times A. So I'm just going to make them to throw this order. Okay. Times probability of 0.05. So that's what will give us the answer. This thing, once we plug it into the calculator, it will give us the answer for the probability that a customer has a credit score of less than 600, given that he or she is late with her current payment. So let me copy it. So the probability then the probability that a customer is has a credit score of less than 600, given that he or she is late on her payment, her current credit card payment is, okay. Now let us we have put everything in the formula. Let us now calculate it, okay, and we'll get our answer. Calculating this, we go to our calculator. So I'm put this in. Where is the calculator? It's right here. So like I said, I wrote it on paper. So let me just follow the paper. I wrote on paper. Okay. So we have 0.25 times 0.40 divided by, okay, 0.25 times 0.40 plus, for the second part, if you remember the second part, it says 0.45 times 0.10. See? So I'm going to put it in calculator. Okay, 0.45, 0.45 times 0.10. Then put the last one plus. And if you remember, the last one is 0.30 times 0.05. Okay, so go 0.30, 0.30. Excuse me. Okay, I think it's I'm gonna put it right there. 0.30 times 0.05. So that will give us the probability we are looking for. That's the customer is late, given that he belongs to A1 group. 0.625, 0.625. So we can go and put it in our workbook. 0.625, 0.625. Just copy it and paste it in our main workbook so they can see it right there. Is 0.625. So there are 62.5% chance that the customer has a credit score of less than 600, given that he or she is late on her or his current credit card payment. Any question? If you have a question, ask me here. Any question to that? Hello? Any question?
No.
Oh, good, good. So that is how you do binomial Bayes theorem. Now, when you have the chance, you can try this once for your practice. Let me introduce you to counting rules. Now, there are three areas, three topics we cover under the counting rules. Hello? Have a question? Hello? All right. So there are three topics we're looking at in the under the counting rule. First one is the fundamental counting rule. Second one is the permutations. And last one is combinations. Let's look at the fundamental counting rule first. According to the fundamental counting rule, it says in a sequence of n events in which the first one has k1 possibilities, the second event have k2 possibilities, the third event has k3 possibilities, and so forth. Then the total number of possibilities would be k1 times k2 times k3 times kn. Now, basically it is multiplying the possibilities to get the total number of possibilities. Let us do this with this equation. It says a coin is tossed and a die is rolled. Find the number of outcomes for the sequence of events. Now, in a coin have two sides. So we use K1 for coin and K2 for dice. So a coin have two sides. So K1 is two possibilities. And a dice has 6 sides, 6. So that the number of outcomes will be K1 times K2. Okay, which is 2 times 6. And that will give us 12 possibilities. Okay. Any question on this?
No.
Okay, good. So now, next one is number 22. It says, a pen manufacturer wishes to make several pens, several different pens. The categories are as follows. Red color, we have red, blue, white, black, green, brown, and yellow. Latex, type is latex. And texture is flat, semi-glass, high class. Use outdoor or indoor. See how many different kind of paints can be made if a person can select one color, one type, one texture, one use. The first thing we do, like the previous example, is to list the number of possibilities. So in that case, we have color have how many possibilities? 1, 2, 3, 4, 5, 6, 7. Latex have 2 possibilities, 1 and 2. Flat has 3, texture have 3 possibilities. As a matter of fact, type have 2 possibilities, latex and oil. Texture have 3 possibilities, flat, semi-glass, high class. Use have 2 possibilities, outdoor and indoor. So let's use K1 for color, K2 for type, K3 for texture, then K4 for use. So K1 have 7 possibilities. K1 have 7 possibilities. 1, 2, 3, 4, 5, 6, 7. K2 have 2 possibilities. So this one is 7. K2 has 2 possibilities. 2. K3 has 1, 2, 3 possibilities. And K4 has 2 possibilities. Okay. 2. So the number of different kind of paste becomes 7 times 2 times 3 times 2. So let me write this down so I can go and put it in the calculator. So we have 7 times 2 times 3 times 2. So let's go and put this in the calculator so you can get it. Yeah. We got 7 times 2 times 3 times 2. 84. 84. 84 possible types of pens. So 84 possibilities. 84 different kinds, 84 types of pens. Pens can be made. 84 different kinds of pens. So that is it. Let's do this one. This one is easy too. It says the digits 0, 1, 2, 3, 4 are to be used in a 4-digit ID card. How many different cards are possible if A, repetitions are permitted, B, repetitions are not permitted, C, repetitions are permitted, but the first digit cannot be 0 or 1. Now look at this. How many digits? 1, 2, 3, 4, 5. And this is the 4-digit ID card. That means 4 slots. See? 4 slots. So there are 5 numbers for 4 slots. This first one says A part says repetitions are not permitted. That means if you use one number, you cannot use the other 4. You cannot use it again. Let's say you use 1, you cannot use it again. So, actually say repetitions are permitted. There are 4 numbers, 4 slots. See, there are 4. You have 4 slots, but 5 numbers. So repetitions are permitted. That means number of cards will be 5 times 5 times 5 times 5. Because say you can it says when it says repetitions are permitted, that means you can, if you use one number, you can use it again. You can use it many times. So you're multiplying all the 5 numbers, and you stopped after the 4th multiplication because you have only 4 slots. So we got 5 times 5 times 5, and that will give us the answer of 5 times 5 times 5 times 5, 625 cards. 625 ID cards can be met. 625 cards can be met. Now, B part says,
I got a question.
Yeah, go ahead.
Why did you do? Why I see you did 5 because it's 5 cards, but why did you times
No,
it?
because it's 5 numbers. 1, 2, 3, 4, 5.
Okay.
So then, and there are 4 slots. 1, 2, 3, 4. So you stop at the 4th multiplication.
Oh, okay. All right.
Good. Now, but second one says repetitions are not permitted. That means if you use one number, you can't use it again. That means this number has only 5 possibilities times the second slot. That means you can't use the number again. So there's 4 possibilities for the second slot, since you cannot use this one number twice. And there are 3 possibilities for the 3rd slot. And there are 1 possibility for the 4th one. Sorry, 2 possibilities for the 4th one. That gives us 5 times 4, which is 20, times 3, which is 60, times 2 is 120, 120 cards. If repetitions are not permitted, there are 120 cards. So the last one says repetitions are permitted, but the first digit cannot be 0 or 1. So the first digit cannot be, the first slot or the first digit cannot have the numbers 0 or 1. So there are only, when you remove 0 and 1, there are only 3 possibilities for the first digits. So you're gonna have 3 times, but other than that, the rest of them, repetitions are permitted. So the rest of them will be 5, 5, 5, because you have 5 digits. 3 times 5 times 5 times 5. Again, you stop at the 4th multiplication because there are only 4 slots. So this gives us 3 times 5 times 5 times 5, which is 375 cards coming in. 375 ID cards. 375 cards coming in. Any other question? Okay, no question. Good. So this thing is gonna time us out. It will time us out anytime from now. If it does, please wait for 10 minutes like we did before and log back in so that we can finish up, okay? So in the meantime, let me check names of those who are here already. Anaya Neil, Anaya Neil, right? Anaya
Yes.
Neil, are you still there?
Yes.
Okay. I got that Campbell. Who else logged in? Bryce. I have Bryce already. Bonner Pulley. Bonner Pulley, are you still there? Pulley Bonner.
Hey, Professor.
You still okay? You're still there, okay.
No, it's not. I'm not that person. But you didn't say my name in the first round. I was hearing the names.
Okay, what's your name again? I forget your name.
Samuel Alborta.
Who again?
Samuel Alborta.
Oh, I checked your name already.
Oh, yeah.
Okay, perfect.
Yeah,
Professor,
I said-
I ain't say my name the first round.
So what's your name, sir?
Onassis Assamani.
I checked it already.
Oh, all right.
So I'm
Do
just
you
looking
got
for
Janaya Blake?
Blake?
I came
Hold
in a
on.
little late, but I'm here.
Blake, Jamal Blake? How you spell
Yeah.
your first name?
JANIYAH
Mhm.
Blake.
Mhm.
BLAKE.
Yeah, I can spell Blake.
Oh, all right.
Yes, the first one that I have from, but I got Blake.
Okay, thank you, Professor.
Heinz, hey, Heinz, how are you? I got your name,
Hi,
Heinz.
it's actually Angel. Me and Tyler is roommates, and I was on the call, but my phone literally died, and I'm trying to join from off my iPad now. But I had even texted in the chat, said Angel Brown was here. I just wanted to let you know I was here. My phone literally just died. I was
Who are you again?
Angel Brown. I'm trying
Brown.
to join
But
back in.
I'm seeing Tyler here.
Yes, I was putting me and her are roommates.
Oh, okay. And you're Brown.
Yeah, and I was saying that I was in your class, but my phone literally just died. Like, it's on a charger now. I wasn't on my computer. I left my computer in the house. Since you sent us an announcement saying that class was online, I just joined from my phone. My phone just died, but I'm trying to join from off my iPad, and it's acting funny. It literally just died like 2 minutes ago.
Okay, no problem. I can see you now. Where is Heinz though? Heinz,
Right.
oh, I checked her. I checked
She's
her.
right
already.
here.
So
She's right here.
Yeah, I got you here, Miss Heinz. I got you. I checked you earlier, Miss Heinz.
Gotcha. Oh, and also, Professor, you marked me absent last class when we was in person last class, and you had graded my homework.
Is it Angel Brown?
Yeah.
You?
Yes.
So I marked you absent last time.
Yeah, last class. Remember I had gave you my paper and you graded it. It was like, don't show nobody, and I was like, all right.
So I'm gonna fix it. Was it for last class?
Yeah, our actual not over spring break, obviously, but the one before that Monday was spring break. We didn't have class on the 11th, but the last one. Yeah.
Okay. I'll take care of it.
Thank
you. You're welcome. Remember when this will cut off in a few minutes, a few seconds. Please log back in after 10 minutes.
Okay.